Worked on some real analysis today and asked ChatGPT some questions about cardinality. I'm going to go briefly through them, but I already have a list of all the questions in a text file to plop into the description for this video. I'll keep it for posterity. The bottom line is that it did a pretty good job. I only caught one mistake, and in one case, actually, it really helped me figure out an issue that I was having reading a proof. Um, so I started just by the basics of, what happens when two infinite sets can have the same number of elements, even though one is a proper subset of the other, just going through the concept of cardinality, and it did a pretty good job of explaining it. Then um, I asked for some examples. They were very good. I used them. I went through these very carefully. They're really well done, especially the one about the infinite sequence of zeros and ones. And that is actually used in rooting. So that's pretty good. Then Cantor's diagonalization argument. Uh, Explained well, went through it. I was reading about it as well, but I really like the way this is laid out. And I actually took notes, which is very interesting. Now, ChatGPT is actually helping me study real analysis. Very useful. Uh, then I ran into a proof in a way that just like busted me out. I couldn't figure out what the construction was about and why there were empty sets. And so I started trying to flesh out of ChatGPT if there was a way I could find a similar proof or a better proof. But here I ran into trouble because what ChatGPT helped me was to figure out what the proof was about in all these following questions. So I asked about the book, and I was trying to understand the lemma, explained it. ChatGPT gave me some really good explanations, but it really wasn't able to give me an alternate proof or an explanation of the proof. And, that's a fairly advanced concept. So I did read it and I learned some more, and I finally figured out what the proof was trying to do, uh, in the sense that the duplicates of the function that I was building didn't matter, and the author should have said, "Hey, they don't matter." So yeah, what's the point of using the empty subsets? And it was not stated in the book, but anyways, and I'm not going to go through this in detail. I always put my questions in the description of the video, and you fine folks can use them for your own use. Uh, So yeah, why is the onto function okay? And I finally got it. I asked the question multiple ways, see if I could get uh, again to that alternate proof, and it gave me more different explanations, all of which were very useful. So that was fine until this one that really helped me. So when I asked, give me an example, um, and how I can prove countable, I finally got it. All right, fine. It's really mapping to the natural numbers, and you just select out all the one-to-ones, and then all the duplicates don't really matter. Then I read some more in the chapter about set containment, and here is where it went a little off the rails, because it described proper subset incorrectly. Okay, so where is it? Let me see if I can find it. If set A is not contained within another set B, that's wrong. I sent in a comment because the proper subset um, just has at least one different element. That's what it should have said. And then I asked it again, and it gave me the correct definition. So the corpus has multiple places where information has been put, and it looks like some more work needs to be done to make all that coherent, so you don't go and get a response that is incorrect, and then you go at it through another part of the corpus and you get a correct answer. Index selection of sets gave me some really good explanations. I learned something. Um, an example, it went pretty well. I learned something here as well. Um, then I tried again. I was like, maybe I didn't try enough. And I'm just going to put these questions for you folks if you want to use them. But I just went around in circles for 2 more questions. So there, I'm done.